Welcome everyone to Quality Improvement Methods, and today we will talk about a new topic extended to the DMAIC and the Six Sigma, which is the design for Six Sigma. Design for Six Sigma is representing the tools that used in the product design or even in a process to ensure that the goods or the service are meeting the customer needs and also achieve the Sigma or the Six Sigma capability, which is the 3.4 DPMO or the equivalent performance. So the Six Sigma comes in the design phase or in the design step where you are designing a new product or a new service. Sometimes it happens in the DMAIC framework or any implementing Six Sigma project, you come to a phase that it needs designing a new product to solve the problem or to design a new process, a complete new process. And here is where is the design for Six Sigma. Also sometimes that comes from the beginning, so the project will be based on the design, not solving existing problem. So the design for Six Sigma, it's a key approach within the overall product development process. So starting from the raw material until you have a complete product. When we use this design for Six Sigma, this is obvious question you may have after we have learned about the Six Sigma and the DMAIC. We use the design for Six Sigma in replacing rather than repairing. So we are going to change or we are going to establish a new product or service, not we are going to solve an existing problem. Improving an existing process will never meet the customer requirements. Your process is way far from the customer requirements, so you need to start a new one, so the improvement will not work anymore, so you need to do the design for Six Sigma. An opportunity to offer an entirely new product or service. For example, your automaker company is decided to do electrical cars, so this is a whole new concept and whole new product compared to the gasoline one. And now this is opportunity for this company to design the product, the new product, based on the Six Sigma principle. Why design for Six Sigma is slow to be used, and we don't see it common to be used compared to the regular Six Sigma or the improvement one that they make. For many reasons, not only those here, but the most common reason is the number of design less than the number of improvement. Most cases when you work in a project, you see the improvement is the most common compared to the number of the designs. Risk and number of resources to design a new product is much. There are risks to start a new product compared to improve your existing one. So always this is going to be an obstacle to be done using the design for Six Sigma. The risk a number of resources like amount of money and time and material to start a new product, it will be much higher compared to improve an existing product. The method and tools are complicated and knowledge requirement is high. You need more tool and advanced tool in the design compared to the improved one. Success of design for Six Sigma demand a mindset, an attitude, leadership, and culture. Well, I believe this is also in both, but in the design for Six Sigma is much higher because you are going to establish a whole new product that will require a new resources and new materials, which is included in these resources, but will include many requirements. And if the leadership they don't have this mindset, that will not help in implementing the project successfully. If we recall the DMAIC that we covered earlier in other sessions. And we look to the design for Six Sigma, which follows the DMADV. DMAIC stands for Define, Measure, Analyze, Improve, and Control. The DMADV stands for the same two first phases: define, measure, analyze, or the three phases, and then we have the design and verify. Here is where the things come. But even in the first three phases, define, measure, and analyze, the objectives are a little bit changed and tweaked to adopt the design concept. For example, in the measure phase, you determine the customer requirements, and in the measure phase, in the DMAIC, what do we need to improve, and can we measure this? This is the objective for each one and how it's different. The analyze, identify functions and generate and select concepts. In the analyze here, define the factors of the influence that make the effect. The design, which is the main element or the main phase, design, test, optimize, design components, and complete the design. In the improve, identify and implement the improvement. In the verify, you verify your design, performance, and implement it. Here, you assure the improvement will sustain. So there is a change in terms of the objectives in general between the DMAIC and the DMADV when we implement the design for Six Sigma. Here is more details about the DMAIC versus the DMADV. In the Six Sigma improvement, which is DMAIC, we define the problem, define the process, and define the customer's requirement that not met in the project or in the product or in the service. Define customer needs in the DMADV. Define all requirements and gain consensus on design generation. That's mean all the impact factors to the design. And in this phase here, the difference between them, both of them are relying on the customer requirements, as you see, but here the customer requirements is already set earlier, and or at least if not set, it was there before, and you are either meeting or exceeding or below the customer requirements, or it could be the variability in meeting the customer requirements. Here, on the other hand, in the design for Six Sigma, the requirements are not set yet. So you have to set the requirements, set all the factors that affect the requirements from the beginning. In the measure phase, extends the problem, data from process, product, and customers. And in the design for Six Sigma, you develop a measure of success, establish tolerance. This is very important. You establish the tolerance where it's you can measure later when you do the design and the verify what is acceptable and what is not. Here it is already there, but you have to measure. You already have a tolerance already set up earlier in the process, and you need to measure that and make sure that you are meeting or you are within the tolerance or not. Determine how crucial the features to be evaluated, how important those features. If you recall, in the measure, we identify the most common causes for the variation. Here, you identify the most also important features that could be cause for variation if you start the production or the service. Analyze the data and process to find the causes of a problem. Create innovative concepts and narrow list of concepts. So you start to have something. You have innovation here in terms of the concept and the design. Whereas here, most of it is analyzing to improve the process or the product or the service. In the improve phase, that's what we do: eliminate the cause of the problem and build safeguards, which is related to the control phase. detail the design alternatives. So you have now not only designing a product or a solution, you design multiple alternatives. So you can select the best one based on testing, and after the testing, then you can evaluate those alternatives. The control, they are similar, and the only difference here is you are controlling your improvement by checking the opportunities for future improvement. Here, the control comes in the testing the design and validate that your design is meeting the requirements, and establish a monitoring system and response plan for your design, for your product or your service. This is more information about the differences between them, how an organization they manage Six Sigma in a company, because you may face a situation where you apply design for Six Sigma, or you apply DMAIC, which is only the improvement. So, and what is the way how the companies or the organizations manage the Six Sigma implementation? The triangle here explains it very easily. If you are improving existing process, مشكلة حالية, you are going to improve it. So their outputs meet customer requirements. The existing process, the issue now is to improve their output in meeting the customer requirements. Whereas if it's a DMADV, the design new product or process that meet customer requirements. So if you are going to design a new product or a service, then you do the DMADV, and the process management element or side here in the triangle is also very essential. Why? Control and manage the cross function to meet the business goals. You don't forget about your business goals. Here you are focusing on the customer requirement if it's existing problem. Here you are again focusing on the customer requirements if it's a new product or a service. But the most important also, and they have to be working all together, is managing all the other divisions and cross function in the process and in the organization to meet the business goals. Your goals is to achieve certain profits at the end of the year. So as you are managing, implementing either one of those or both of them, you have to pay attention to manage your process to meet your business goals, not only your customer requirements. And this is one of the things that in the DMAIC or the DMADV, when we talk about customer, we always talk about the internal and external. And when we come to the internal customers, we define the requirements in terms of the stakeholders of the process internally, like the business goals and so on. But you need to make sure how you manage those cross-function in the process to maintain or achieve or exceed your business goals while you are maintaining or implementing the Six Sigma. This is how you, this is the triangle show you how you balance the management of Six Sigma in your organization. In the design for Six Sigma, it's relying on 4 principal activities, and those are very important activities, and commonly or logically it's a common sense that you will have those activities in order to have design for Six Sigma. The first one is the concept development. The second one is the design development. The third is design optimization, and the fourth is design verification. In the concept development is where you determine the customer requirements. Your product functionality, it has to be based on the customer requirement, the technology capability, and the economic realities. You don't design a product that only meet the customer requirements, but you don't have resources or you don't have the technology to build it. So in the design, which is the concept development, after you collect the customer requirement and know what is the functionality they are looking for, in the product or the service, you have also to consider your current status in terms of the economy and technology or resources that can meet those customer requirements. In the design development activity, you focus on product and process performance issues necessary to fulfill the product and service requirements in manufacturing or delivery. So here you are focusing on the process. After you identify the requirement and you identify the concept, now you come in the development of the design itself, but you start in the process. How many steps? What are the resources? What are the function that it's going to be done in every step, input, output, all that will be in the design development. And you have also the third step, which is related to the design, but here after you develop the process and the issues that related to that one, so you come and resolve it and make sure that you are meeting the requirements, you come to the design optimization. In the design optimization, you minimize the impact of variation. So you identify the sources of variation could impact on this process here, on this design here, okay? So you identify them and also minimize them and create what it's called or known as robust design. So with the minimum variation or almost no variation. The last step, which is always we do the assurance in the quality. If you recall, all the time in the quality, we consider quality control, quality assurance. The quality, it's an ongoing process. It's not just you solve a problem and you leave, or you propose a solution and you just implement it and you leave, or you close the project. You always should have a continuous loop or continuous monitoring, and that's where is the design verification as one of the 4 principal activities in the design for Six Sigma, ensuring that the capability of the production system meets the appropriate Sigma level. So you make sure that the product or the service or the process you design is meeting the appropriate Six Sigma that you have established from the beginning. So collecting the requirements and determine what is the requirements, and then focus on the process, on the product issues, and try to establish the process and resolve all the related issues. In the optimization, you minimize the variation of the production or the service transactions, and then you ensure the capability of the product or the service that meeting the appropriate Sigma level. Those are the 4 key activities or principal activities in the design for Six Sigma. And the tools for DMADV, as we talked in the DMAIC, Six Sigma methodology has a very good advantage, and that's why it's commonly used in improving and solving problems. The idea of the design for Six Sigma or the methodology of Six Sigma can carry a lot of other methodologies and contain other tools that serve the purpose of the Six Sigma. Those tools here for the DMAIC are not the only tools, definitely. As we said in the DMAIC, those tools we covered, they are not only tools, they are common to be used. It's appropriate to the level of the audience here taking this course, but there are definitely many other tools for both DMAIC and the DMADV, and it's keep updating, and it can carry any other methods. Like when we talked in the improve phase, we said that the Six Sigma methodology can carry the operations research and simulation, and you can watch that in the recorded session related to the DMAIC framework. In the tools for DMADV, some of the tools that we covered in DMAIC can be implemented here in the DMADV, and it's commonly to see that is very common. That's why we put them here to show you that there are some tools commonly used between them. The purpose is different here. A voice of customers, you establish now and create the voice of customers or collect the voice of the customer requirements, where there you measure it and identify it for something that exists already. Those, the one on the gray color here, those we already covered them on the DMAIC recorded sessions. Maybe, for example, here the design of experiment is the only one that is covered in a whole different course, so there is no need here to repeat it because it's a whole new and separate concept. But starting with the define phase, let's say voice of customers, critical to quality tree, project charter, all this is covered in the define phase of DMAIC, so we're not going to repeat them. We will take a new tool here, which is quality function deployment, and it's very important tool if you are going or planning to design a product or even for a service, okay? The major phase tools, there are plenty. Those are not definitely the tools only, but the capability performance is one of the tools that we already covered to calculate the CP and the CPK. And you can also do that in the design for Six Sigma. Also here, the benchmarking, which is one of the common tools to be used in business, as well as for design for Six Sigma. Before you start your product and designing your product, see what is the best practice in the market, or compare your competitors in the market and see how they are performing before you do the benchmark, before you do your design. Tools for analyze, we have done force field analysis, interrelationship diagram, simulation. The simulation is covered in a whole different course, but those already can be implemented in design for Six Sigma under the analyze phase. We will introduce a new tool, trace. It's a methodology itself. It's not just a tool. It's a whole method. Some people even they compare the trace with Six Sigma methodology. So we will introduce this one when we come to the analyze phase. Tools for design, we have plenty, and those are not the only one. Again, we have mistake proofing and Poka-yoke, if you recall, we already covered that. The brainstorming, definitely one of the common tools that to be used in most solving problems. Design of experiment, factorial analysis in the design of experiment, regression analysis can be done, correlation studies, all that can be done here. Failure mode and effect analysis, FMEA, and that's already covered in the quality control sessions. The PO matrix is the one that we will introduce it here in the design phase. And the last, not least, is the verify phase. We have covered the activity network diagram, statistical process control, plan do, BDCA or Deming cycle, gauge repeatability and reproducibility, R and R, gauge R and R. We covered that in the mini tab review, and this is for the consistency measure. And what we are going to introduce in the DMADV is the response planning. Those tools that we are going to cover them here in the DMADV, most commonly to be used in the DMADV, but is not limited that you are not able to use them if you are implementing DMAIC. Now again, it's depending on the objective of your project. If your project is designing a new product or a new service, or it comes after the analyze phase that you find the solution is to do that, and you decided to design or a product or a service, then you will move from DMAIC to DMADV. So basically, and this has happened sometimes, and I've seen it before, you come in this phase here in the analyze, and you and the stakeholders and project sponsors, you found that the solution is not going to improve the existing process, that they need to establish a new process or a new product or a new service, a whole complete new one, then they move from the improve into the design instead of the improve phase and the control, okay? So those tools can be used between the DMAIC and DMADV, but it's commonly to be used in the DMADV. And the cycle of DMADV is similar to the DMAIC, is continuous cycle. And after you have designed it, then you launch that product or the service, you basically are going to implement the DMAIC to keep, monitor, and improve the process over and over. The define that we said we're going to cover the quality function deployment, QFD, as one of the tools that we are going for the DMADV that we will cover it today. A system for translating customer requirements. Remember that in the activities for the design for Six Sigma is we have to identify the customer requirements. So this one is very good tool to translate the customer requirements into appropriate company requirements. So they are not become anymore just a customer requirements, it's a company now requirements at each stage, from research and product development to engineering and manufacturing, marketing, sales, and distribution. QFD is an analytical process which provides an approach to deploy the voice of customer through all aspects of the product process or product development process. It is a planning tool. It's also will include the benchmark, even though we are going to cover the benchmark in a separate tool in the measure, but also QFD can cover the benchmark here because it has a planning tool and compare yourself with other competitors and see where are they standing or where are you standing against them. The planning tool here provides the depth and evaluation of a product, whether the technical side or with the respect of the market side. The quality function deployment are known as the House of Quality, HOQ. House of Quality is one of the tools that use in the quality function deployment concept, and it is the most common used tool for translating the customer requirements into company requirements. How they do that? What are the steps to develop the House of Quality? You follow these 7 steps. You list the customer requirements as what's, ما هي customer requirements, list of technical descriptors, house as house, يعني كيف نحصل على هذه requirements technically. Develop relationship between a matrix between what and hows, يعني between the customer requirements and the technical descriptors. حط أو أعمل matrix للعلاقة بينهم. Who's the stronger? Who's the one علاقتهم قوية أو طردية أو عكسية. Develop an internal relationship matrix between hows, between the technical. Put an relationship matrix, and the reason is you have to identify if the technical requirements are in a relation to each other, or they can be separated in terms of the assembly, in terms of the manufacturing from third party, how they are depending on each other, so the specification between them, or how they affect each other. So a relation between the customer requirements and technical descriptions. Then a relation between or among the technical descriptions. This is the 4th step. The 5th step, competitive assessment. And here is the benchmarking, okay? The 6th step, develop prioritized customer requirements. So you prioritize the customer requirements, which one is the most needed until the one the least needed, or rank them, let's say. The last step is develop prioritized technical descriptors. So which of those technical descriptors are the most important, which is based on the also the prioritizing the customer requirements based on the results. You will see it from the matrix. We will see all that in example, but this is how you do the house of quality. House of quality looks like that, similar to the house. There is a roof, there is ceiling, there is a floor, and the main room, they call it here in the middle. The roof of the house of quality recognize the correlation within the product characteristics. يعني المواصفات حقت البرودكت technically wise relation between them, العلاقة بينهم, you see it here in the roof, okay? And here how this is the technical descriptors اللي هو مواصفات التقنية. You see it here in the ceiling. In the side here, what? This is the customer requirements. And in the middle here, the relationship between the technical requirements and the customer requirements. The bottom here is showing that or prioritizing more specific targets, values for technical specification, and relating the how and what and how you satisfy them. So basically here is the results or the ranking. You would see them here, which one you should focus first. We will see now more details about house of quality. This is in general the main sides or elements in the house of quality. Here is more details and with a filled house of quality one, and we will do another example in the next slide. So starting with the roof, as you can see here, there are key legend in the box here. The triangle shows that 1 means weak, circle, empty circle means that 3, which is medium relation, and the filled circle, that's mean strong with a 9 scale, strong relationship. And what does mean that? Means if this technical requirement here, for example, let's say built-in self-test. So you go up and you see the triangle here intersect with this column. So you start going down here on this side. That means the built-in self-test and the computer-controlled, those technical requirements have a weak relation. So the relation between them is weak. Whereas in the mean time between failure, that's mean الوقت اللي هو متوسط الوقت بين الإعطال أو في product, it's intersecting here with the built-in self-test with a strong relation. That's mean the mean time to failure has a strong relation with the built-in self-test. These are technical requirements, مواصفات technical, تقنية. Based on what? Based on what the product you are developing, your designers, and also your customer requirements. The customer requirements, as we said, on the side here. And you see it's titled Customer Requirements. They required high degree of compatibility, ease of operation, capable of close tolerance, and so on. Here are the customer priority. You remember we have to prioritize the customer requirements. This is their priority. Triangles mean weak, and the filled circle is mean high. When they say high reliable here, that means the customer requiring high reliability in this product, and they consider this is the most one of the most important requirements. This one here in the main room or the main body, the relationship between the technical requirement and the customer requirement. So the customer requirement like high reliability or high reliable is depending definitely and obviously with the mean time to failure, and the relation between them is strong. But you can see that the computer controlled, that shows a weak relationship with the high reliability. On the right side, you may ask what this represents. This represents the competitive benchmarking, and you identify the companies in the market, including yourself, with letters or symbols. For example, let's say A maybe represent this company, B represent another company, the same as for C. And the scale for each of those company in terms of those customer requirements. So from 1 to 4, the scale here, 1 is low and 4 is high. So you see where are you standing, and we will explain that also in the next example. So here the competitor comparison, you visualize the comparison. So tracking this line here easily make you track the customer requirements. Where are you standing compared to the others in the market? It shows also direct feedback from customer service and shows them where are they standing. Here it shows at the, as we say, the lower side, it shows the selection or the result of this relationship between the technical and the customer requirements. So we will come to that in the example and see how this number is calculated. But here, just to explain in more information about how this shape looks like and what each each division in the house, what they represent. Here, as we said, the design requirements interact with each other. So the relation between the technical or the design requirements. The main body shows the relation between the technical or the design requirements and the customer requirements. The what shows the customer requirements and the prioritize them. And the relative importance here then lower is the results of calculating the total of the sums of each column, which multiplied by the importance factor. We will see now a very simple example of designing a drone. Everyone knows the drone, that اللي هو الطيارة المسيرة من بعد، أو ممكن تستخدم للتصوير، تستخدم لها استخدامات كثيرة. The drone design here, they used House of Quality to design it and also compare themselves with others. The company used this template here called Fly Company, who developed this House of Quality for their drone. The requirements from the customer, they have 12 requirements, starting from the style and up with the long remote battery life. There is the long drone battery life, which is the self-drone, the airplane here اللي هو الجيت نفسها الطيارة. and long remote battery life هذا اللي هو الكنترولر الباتري لايف حقته. There are other requirements here like quiet, super HD camera, stable, long range, and so on. All these are the customer requirements. The importance, they give scale from 1 to 5. 1 means least important, 5 is highest important. Al battery, we can see that receiving 5, that means very high importance compared to others. And we see here the style is 2 for the requirements in terms of the customer, so it's not considered to be high, is considered to be low. Now, for the technical requirement, they listed the design requirements for this drone, starting also from 1 to 12. Now, in most cases, you will have a design requirement for each of the customer requirements. Sometimes you have more, sometimes you have less. Like here, for example, you can have not equal numbers, but also if you have the same requirements, this is depend really on your customer requirements. Sometimes the requirements will require more than design feature or design requirement or element, and sometimes 2 requirements from the customer will be matching 1 technical requirement. So now here we have 12 customer requirements and we have 12 design requirements, starting from the style. Jury, they would be responsible for the styling, obviously here. until the minutes, which means the time for the battery. And these are name of the electronic or computer chips, W26 chip and W11 chip. The size, the noise, all these are design requirements here in the ceiling of the house. And we have on the left side the customer requirements. Now we start either from the body room or the top room. They are independent, so you can start with each one of any one of them. So let's say that we are going to do the customer requirements and the technical requirements. So you start one by one. The stylish with the styling jury, it's very strong relationship because those the team who are going to do the design. And if هتشوفوا سيارات في ناس مصممين للشكل أو الديزاين حق السيارة, فthose definitely will be a relation between them is important. And the style and the weight, there is a medium relation, but not as strong as the styling jury. For the remaining design requirements, if the style there was no relationship between them and those design requirements, so you just leave them empty. You don't have to fill them. If there is a relation, even if it's weak, so you put it. Like what we have here between the weight and the style, okay? You keep doing the same, so we'll take the long battery life here. It has a strong relation with the minutes, which means the design requirements, how many minutes it will serve the battery for both the drone and for the remote. That's why it has a strong relationship here. And it shows a medium relation with this W11 chip. Maybe it's the one responsible for the battery or the consuming the energy. The same for W26 in terms of the drone battery, but for the remote battery, it has a weak relationship, okay? So these are the relation between the customer requirements and the design requirements. Here, just to identify, for example, a strong relation between a stress test and the durable body. Definitely, the stress test is to test the durability of the body, so that's why it has a strong relation. And the lines here, just to show you an example, how you track the column and the row in the requirements. So this is the main room. For those numbers here are sequence from 1 to 2 until 12, the same as from 1 to 12, so they are not scaled, okay? Now let's go to the roof. The roof shows the relation or the interaction between the technical requirements or the design requirements. How we read or how we develop and fill the roof. When you develop the roof, there is a template for that. Ready house of quality, and you just fill on that one, but you have to develop a matrix like that where you can start in the matrix from any of those design requirements, and you can intersect with all the other requirements. So for example, if I want to see the relationship between the styling jury and the weight, I will start from this column here and move to the right, and then I will intersect with the first point that comes on the top of this requirement. So that will be, this point will be the relationship between the styling jury and weight. Let's take another two. Let's take, for example, the kilometers and the W11 chip. So let's take 7 and 9. So 7, you go up here, and then when you hit this triangle, the first one, you start to moving to the right until you intersect with the point that on the top of the W11. So here we have this point here, and that's where the W11 chip, that's intersecting with the kilometers. Again, let's take another example. So for example here, let's take the weight and the size as we have it filled here. So when you come to the weight, you start moving to the right until you come to the point where it's above the requirement that you are planning to intersect or to study the relationship with. فتمشي باليمين هنا إلى أن تصل النقطة اللي تتقاطع مع الريكوايرمنت اللي أنت تبغى تقيس معها. And then you go down. This consider هذا السكوير considered to be a correlation point between them. And what are those signs? All are in the legend box, but here we explain it. So the 1 minus means there is a negative correlation. The 2 plus means that a strong positive. If there are 2 minus, a strong negative. And if there is 1 plus, that's mean a positive correlation. You can use your own symbols. You can use your own scale. This is the way how you would like to do it. It's up to you, as long you use a legend box, explain the symbols or the numbers you are going to use here, okay? Now, for example, between the weight and size, the weight and size, there is a strong, between the weight and the noise, because we come to the intersect point and then we move down. Okay, again, let's explain it again here. We come to the weight and you go up until you come to the point where it intersects with the column here. فأنت بتاخذ المنحنى هنا، بعد كده تنزل تشوف هي بتتقاطع مع مين؟ مع هذه. إذا كنا نبغى الويت والسايز، we go this way here and we come down here. فحيكون الفيلينج in this point if we want a weight and size. Okay, if we want the weight and size, it will be at this point. Again, let's explain another example here to clarify that point. So because the matrix is very small here, you can enlarge it, or even you can draw lines like this one, the dash lines here, to show where are the points you are targeting, regardless of you have a matrix or no, if you couldn't develop the same matrix. So let's start with, let's take this one here. This point is intersecting between what? Between the minutes and the W26. And the other minus here, the double minus, is intersecting between the minutes and the W11 chip. So you start with the point and see the two sides, where are they going? لأنه النقاط هذه اللي هي في المنتصف هي تربط ما بين نقطتين في requirements in the design requirements. So this points here is linkage between two requirements. For example, here this point is linkage between 4 and 2. This point where is only 1 minus or 1 negative correlation, it's intersecting between the size and the style jewelry. Okay, any point, let's say the top point here, this one here, the first one at the top, it's intersecting between the minutes and the styling jewelry. Okay, the first one and the last one are intersecting in the top point. So you always look to the point and the intersection columns, and those columns are going to refer to the design requirements are interacting with each other. Again, the easiest way, if you couldn't track it, to draw lines like this. The lines are very easy to track. You see the dash blue line here easily shows you where the noise and the weight are intersecting, and you will represent them based on the designers, they said those have a strong positive correlation. Strong positive correlations mean that if this guy here, the weight increase, then the noise will increase. And the same if it decreases, okay? And that's why you see a strong relation. That means they are very related to each other. And here for the negative correlation, that means if the styling jury they increase in terms of the stylish of the design, the size will decrease, or vice versa. If the size increase, then the style will be decreasing. So there is a negative correlation between them. Now, what about those arrows up and down? Those are maximize or minimize objectives. Either you would like to maximize them or minimize them. This is also based on the customer requirements that's set already or collected here. And after the evaluation of the engineers, they identify whether to increase or decrease this technical requirement. For example, they would like to increase the style. They definitely would like to increase the battery or the minutes. They want to decrease vibration, I believe here, and the noise. Definitely, they want to decrease it. The size and the weight, they would like also to decrease those, and they increase the others. So these are just to show you what are the objectives for every technical requirements based on the customer requirements. So here again, the relationship between the technical requirements, these mostly set up by the designers because they are the specialists and knows how they are correlated to each other. In this one here, you can do that with the designers also, but here where the customer requirements collected needs some kind of investigation and collection of data. This one, we will go to the right side and then we'll come to the lower part. The right side shows you your performance compared to competitors. We have a scale from 1 to 5. 1 is the low and 5 is high. And F is standing for the Flyco company, the one that developed this template. S standing for Samsung and P for Panasonic. And now they would like to see how they are performing compared to others. The customer assessment says that in terms of the style, Fly company fall in the middle, whereas Samsung fall at the highest. But in the battery of the remote, Fly company falls the top, and Panasonic then followed, and last is Samsung. The long drawn battery life, here we see it also at the top, is not 5, but also in the top compare of the competitors. Now you can tell that is the line here for your company in all the customer requirements. And this could be based on previous designs or could be on your beta test. For example, you designed a product, you give it to some users to test it and give you the feedback. So this is either one of those, okay? Now you can tell how you are performing easily, graphically and visually. You can just track this line and you see where are you standing. So the company here looks like they are in the top or above the average in most of the requirements compared to others. They are falling here in the highest in terms of the long remote battery, also in the quiet of the drone and the lightweight. Then they are in the middle at 4 other requirements, 5 other requirements. They are only lack or below in the style. So and also here in the durable body. Okay, this is a very weak point here in the durability of the body. And easy, you see how even if these requirements are high, more or double the number here, it's easy to track it by having this line. easily we could identify this point here, that the durability of the body is low compared to others, but in the others they are performing either at 4 or 5 scale. This is how you conduct the benchmarking. Next to house of quality, let's go to the last part here in the house, which is the floor or the lower part. And the importance factor here, this one here, rate each of the function based on their level of performance, and the lower level or foundation يسموه البيزمنت خلينا نقول this part list more specific values for technical specification relating to how used to satisfy voice of customers. House here, how it's used to satisfy which is the voice of customers. How we do that? Here are more technical specification first, also by the designer. For example, the minutes, 26 minutes is the target, and stress test عفوا 29 kilogram per Newton square meter, kilogram per square meter. Sorry. For example, the size here, the dimension, height, weight, and length, the weight for kilogram, and the light jury, they target it as 5 to 8 people in the jury, يعني 5 و 8 محكمين للlight jury. These are also in the company, they have to decide it. How these values are found, you basically, or what they represent the importance of this design requirements, or the house we call them, in terms of satisfying the customer requirements. طيب, how we calculate this number and how we interpret it? We start adding the value. How we add the value? Each of those symbols has a scale. The double circle has a 9 for the strong relation, and the empty circle has 3 for the medium, and the triangle has 1. So basically, you replace this numerically into 9 because it's a strong relation. When you replace it with 9, you multiply it with the importance of that customer requirements value, which is 2. 2 times 9 is 18. So this value here, it will be 18. And then you do the same here for the high quality finish. You multiply the 2 with the 3. Why the 3? Because the circle, that shape, has a value of 3. 3 times 2 is 6. So we have 18 here and we have 6 here. And then the last one is 3 times 3 again, because the value of the 3 is 3. So we have 18, 6, and 9. If you add them all up, you will get 33. The same, you do it for the remaining. For example, let's take another very easy one here to just validate. The horizontal blades, I believe, or shape of the drone has one correlation between the HD camera, the horizontal pixel, I believe. Yes, this is in terms of the thing in the resolution. So yeah, that's why they have the 4K resolution here as the setup target. The relation is very strong, and it is 9, and 9 times 5, which is the priority of that feature in terms of the customer requirement. 5 times 9 is 45, and that's why you see 45 here. So if there is other scales here, you add them all after you multiply them with the customer requirements to get the total number, okay? Again here, for example, the triangle is 1 times 3 is 3. The circle 5 times 9 is 45. Why it's 9? You go to the value here, 9. So 1 and 45 is 46. And then you multiply the 3 times 3 is 9. So you add up the 46 with the 9. So you get the 49, the 57. And that will be the total for the target value. That will be the total for the target value. The 3 times, okay, let's add them here up. The 3 times 45 plus 9, yes. So we have 3, I just double check here. 3 times 1, 3 times 1 is 3. 5 times 4, 5 times 9 is 45, and then 3 times 3 is 9. So you add all these values, 3, 45, and 9. You add them all up to get the 57. And after you have them all summed, you add them all together horizontally. So you get the total sum horizontal line, which is 634. How you get the percentage? You divide each value of those over the total to get the percentage. And it's just another representation of the importance weight. Here we have the importance, and here is the importance weights in terms of the percentage. Sorry. So here we have 5% because we divide 33 over the 634. Here you divide the 35 over the 634 and you get almost 6. Until you get the last one is 24. Here, that's mean these are the highest importance. This guy here, the minutes, which is the long or the lifelong for the battery for both the drone itself and the remote. So that is the most important feature for the technical requirements that meet the customer requirements. And then you can carry it on. You see which one next. You see here is the W26 chip. And I believe because it's related to many factors that are also important to the customers, like self-directing, programmable paths, and also the battery life. That's why it comes next. And then we have the 9, and we have more than one has a 9%, like W11 chip, and also the noise output, and so on. So here it shows you the importance of each factors or each technical requirements based on the customer requirements, how you can satisfy them, and you prioritize them in your design. This is how you do the house of quality. I hope this was a good example explaining how you conducted and developed the house of quality. We will stop here. We will stop here for now, and we will continue with the measure phase in the next video session. Thank you for watching.